All right, Algebra 2, I'm going to show you these two examples for today. We're dealing with 8-2 mixed rational exponents. I'm going to go ahead and show you. So there's that. I taught you two different types of notations for these problems, and I'm going to write them out now. So I'm going to start with solving this one. This is actually number 1 on your assignment. I'm going to start by showing you what we know. The denominator is always inside that little crook right there. And then there's two ways you can write this. The ways I've taught you, which involves this, putting the 3 here, right? But then there's the other way as well. And you are responsible for both. Today is an example of when the other way is actually kind of beneficial for your head. So, see this right here? This right here? This one on the left tells you, hey, we want you to take the cubed first. Cube this number first, and then do the 5th root. This one over here is saying, hey, do the 5th root first, and then cube it. Both of these are accurate. Both of these will get you the same answer, but we're going to be working with this one today, the one on the right-hand side. And what this gives us is, cool, what do we need to know about this? So we have to break this apart. So all we have to do when we first solve this is find the 5th root of negative 243. And once we find the 5th root of negative 243, the best way to do that is your number list. Generate 2 to the 5th equals 32, 3 to the 5th equals 243. Now, sorry for my jumping video there. I wrote down something wrong, but this is correct. So what we know about odd exponents, if it's an odd exponent, the negative can be in there. So technically, what we found is negative 3 raised to the 5th power is equal to 243. You're going to have to use calculator tricks sometimes to do this. You'll have to figure it out, but I want to see the steps more than the answer. Because you can literally type this one into the Desmos and get the answer. But do you understand how to break it apart is really the skill you're learning here. So negative 3 raised to the power of 5th is equal to 243. So check out what happens. So if you look at down here, negative 3 to the 5th, and this, I can rewrite this thing on the right just like this. I've now solved this answer. This 5th root of negative 243 is negative 3. So I end up with negative 3. And again, if you're wondering where I got that, it's right here, y'all, over here on this side. If I took the 5th root of negative 243, it gives me negative 3. But I still have this 3 up here that I have to raise it by. And then that gives me negative 3 raised to the power of 3 is negative 27. So that's the answer for that one. I'm going to go ahead and switch colors and work in blue over here. Watch how I set this one up. This one's great because it has a 1 in the numerator. So I'm going to set it up like this. 27x to the 9. Oops, that's a 20x. 27x to the 9, y to the 27. This is going to be rewritten. I'm going to rewrite it using the other method, this one. 3 goes down in the denominator, and then this is going to be brought up to the power of 1. Now keep in mind, power of 1 is just kind of redundant. We don't have to do much with it. So it's just saying find the cube root of this. It's saying find the cube root of this. So here comes this little practice. Break up your numbers. Break up your letters. It's this thing we've done a million times by now. And yeah, it's not that exciting. The cubed root of 27 is in fact 3. X to the 9, I know it looks terrible, but 9 divided by 3 is x to the 3rd. That's how I do that, this number divided by this number. And then 27 divided by 3. Now this one lucked out because these were all in good order, right? 27 divided by 3 is 9. But what if I would have had, let's say, oh yeah, let me put it back together first. So everything is out of the house. And now everything's out of the house. It's still technically being raised to the power of 1. But we don't have to worry about that because raising things to the power of 1 is silly. So we end up with 3 times x to the cubed, 3x cubed times y to the 9th. So that's what we end up with for our answers here. I'm going to be walking around today. These isn't that good of a lecture. I'm not even going to be lecturing that much, to be honest. Today is just straight up work day and tutorial day that I'll be able to help you one-on-one master this stuff. We've had plenty of times to learn this, but it's just kind of it's a weird thing still. All right. Bye.